Hi, all, welcome back to the last part of this introduction section of explainable essential concepts, methods, and practice. And once again, I welcome you all to our first real world case study, healthcare. Healthcare is one of the most critical domain where interpretability isn't optional, it's an essential one. Imagine an AI system predicting a risk of cardiovascular disease from patient health record or medical image. Okay, a prediction alone, high risk is not enough. Like the prediction says that the patient is high risk, that's enough for for a doctor to confirm that this patient is of high risk. Not now. A doctor needs to know why the model made that conclusion, what features influence the decision, and how much each factor mattered. Without this transparency, doctor may mistrust or ignore any AI recommendation. For worst case, doctor may make this decision and that harm the patient. Okay, this is one of the example. Here you can able to see the patient record, the patient lung images fed into our model. Okay, our model says that the patient is affected by COVID-19, and you can able to see this box, right? This box says that this is the high risk area where the COVID-19 virus is affecting this patient. So just because of this, I am saying that this person is affected by a COVID-19 virus. Okay, when your doctor has this explanation, he will able to get it right, he will trust us our model, right? That is what explainable AI does. In another example, a study involved use of AI model, explainable AI models like shape, line, to show which clinical variable most influence risk prediction for individual patients. This work showed that adding explanation helped doctors understand and trust the model's outcome, increasing the confidence in AI supported diagnosis. In another medical applications, explainable modules were added to ECG classification models to visualize which part of ECG waveform influenced the detection, helping doctors verify the result before acting. So in healthcare, interpretability transform AI from a black box into an collaborative tool with doctor. Next, let's look at finance and another high impact domain. Banks increasingly rely on AI for credit scoring, loan approvals, and fraud detection. However, regulatory regimes like GDPRs and consumer protection laws requires transparency, like why was credit denied, what factor determined risk. Explainable AI makes such decision explainable. Okay, now see this example. Here, a bank uses some risk model, okay, with the help of their client database, and this model shows that this client is risky, and we don't know, like stakeholder one of the person is asking justify why the client is risky, and I want to know what decision made with this, and I also want to know what rationale behind this decision. So it is all black box. But if our system explain these questions without they asking it, will we trust our model, right? Yeah, that's what explainable AI does. In another example, major financial institutions have integrated techniques like shape and line to interrupt credit risk model. These tools help identify the most important features such as income stability, credit history, and payment behavior that influence the loan decision, and then clearly communicate that to customer. Explainable models also reveal hidden biases in credit scoring that might unfairly disadvantage certain groups, allowing banks to adjust their criteria and improve fairness. In fraud detection, explainable AI helps analysts understand why a transaction was flagged by AI, reducing false positive and improving their investigation efficiency. Now we move to criminal justice. AI systems are used to assess risk the likelihood that a person will reoffend, and sometimes such scores are used to inform bail or sentencing decision. But without transparency, these systems have been shown to embedded and even amplifies bias. For instance, the compass tool used in US justice system. This is the example of a compass tool. And output we get from the compass tool. Okay, this tool criticized for producing biased risk score against certain racial group. Here you can able to see that he is one of the high risk person, but it shows low risk one, and he doesn't charged of anything in his history, and only arrested for one resisting without any violence one. Okay, but he is classified as high risk person. So this compass system justice given a score based on their racial groups, not based on their history of records. So for this alone, this compass tool is criticized more, and when we incorporate our explainable AI into this compass system, which will explain why a defendant risk score was high, identifying key influences like prior offenses or age, allowing legal stakeholders to access the validity and fairness of the AI reasoning. This fosters accountability and drives better, more equitable decision, because interpretability tool can help uncover which factors contributed to a high risk score, making hidden biases visible to. Now come to education. In education, AI systems support personalized learning environment and early warning systems that identify students at risk of failing or dropping out. A model may predict that the student is at high risk, but for teacher and counselor, the prediction alone is not actionable. They need a context. Did poor attendance matters more? Was it weak performance on quiz? Or he or she doesn't have any engagement? So this explainable AI will improve this system. For example, through feature important analysis, educator can see exactly which factors led to the prediction, allowing them to tailor the intervention, such as giving an extra tutoring class or giving the counseling, or they may conduct any engagement programs. These explanations not only empower educator but also help student understand their strength and weakness, supporting human-centric learning environment. Next, we move into autonomous system and transportation. Self-driving cars make complex real-time decisions whether to stop, turn, or avoid obstacles. These decisions must be explainable to developers, regulators, and someday passengers too. I hope so. Researchers have studied frameworks that explain autonomous vehicle decision by breaking down sensor inputs, environmental conditions, and confidence measure, helping engineers and regulators understand why a particular action was taken. For example, stopping at an intersection due to some pedestrian detection or some animal crossing, so anything. In fact, there is an ongoing research into an explainable AI frameworks for end-to-end autonomous driving that provide detailed rationales for driving actions. Why I turned left, why I am not turning the right, like that everything will be given. Will be instruction given by our system, enhancing the trust and safety while aiding regulatory compliances. Without interpretability, it's difficult for society to trust such systems and technologies like this, especially in scenario where mistakes can cost life. Am I right? Now let's look at engineering and manufacturing. Industries uses automated visual inspection tools, a tool which uses AI system that detect product defects on assembly lines. These AI system might catch flaws faster than humans, but manufacturing engineers need to understand why specific items were flagged as risk. Recent reviews of explainable AI application for a visual inspection shows that post hoc explanation methods help operators see which visual features the model relied on, enabling them to improve quality control processes and reduce false rejections. For example, here you can able to see that the uh, the thing that this component is made as rejected and this one is okay, and here the defect detected, there is an explanation given by a system that shows that defected is detected just because the pins are misaligned in this one, therefore I am rejecting this one. Like this, the explanation is given by the system is correct, they can go with the alignment of the pins, like they can move into that quality process and make sure that the quality is perfect, then they can move into a system like this. Okay, this boosts trust in automation and speeds up maintenance troubleshooting. Following with me, right? Now we move into an energy and environment. Energy and environment also benefit from explainable AI. Believe me, consider a predictive maintenance, like predicting the remaining useful life of the equipments like grids or turbines or any other thing using digital twin system. Traditional AI may predict failure, but operators must understand which feature or sensor readings led to this prediction, because some sensor may be fault. From that sensor, how can I believe that this prediction is correct? So a case study in explainable digital twin system used interpretable ML to explain predictions, making AI recommendations actionable for maintenance teams and improving trust in these systems. So here if I have a energy consumption systems, if says that the turbine is fault because of this, and that is that because of that sensor. Okay, the some sensor is in this turbine system. If the reading from this sensor is made led into this decision, then they can check first, they can check with the sensor quality. If the sensor is okay, if the sensor is good, then we can take that decision. If already the sensor is in the problem and if we take that decision, we cannot able to do anything, right? We cannot trust our system, right? This is what happening here. If the explainable AI is here, can understand, I can trust the system and I know how to correct an error that too. Okay, so this is not only avoids costly breakdowns but also supports environmental sustainability by optimizing energy systems efficiently. Am I right? So now we move into our day-to-day process in natural language processing. In natural language processing, AI models classify text, extract meanings, or generate summarize. Yet language model, especially deep learning ones, can be a complex one. Explainability techniques like attention visualization and feature attributions help reveal which word or phrase influence the classification. For example, you have a WhatsApp group or WhatsApp, you open the WhatsApp and type good. The recommendation will be, if you are typing in the morning time, it will be give morning or any other thing. At first recommend, it would first recommend morning. Then if you often uses work, then the next recommendation will be your work, good work or good morning or good job. If you often work with good work or good job, then it will show morning as a first one, then it work as a second, and job as a third. Okay, why? Do you know why? Because What if explainable AI is there and says it is a morning, that's why I am telling is good morning? That would be better, right? That's what we need, explainable AI in our natural language processing. But in legal document analysis, like we have so many analysis tools for getting the legal document to be analysis. Explainable model can highlight clauses that led to certain interpretations, helping lawyers and judges understand why a document was classified in a certain way. This improves trust in automated language system and supports transparency in sensitive domains. Now we move into an interesting one, computer vision, which deals with the images, and while deep models are powerful here, they are also complex, more complex. Explainable AI methods such as saliency maps and grade cams shows which part of an image influenced a decision. For example, in medical imaging, these provides visual explanation for tumor classification, helping doctors verify correct region were used for diagnosis. Like we have seen in our medical imaging, right, in the health care, like why our COVID was predicted, because this lung in this lung X-ray we have some part of this is affected by our COVID-19 virus. Am I right? You can remember that one, right? So this can be in a computer vision part too. And one of the most interesting example, if you all like cricket, then I will go with this cricket example as well. Here you can able to see that this ball prediction. Am I right? What if our prediction, if we don't know how the prediction is occurs, we just know that the ball is there, and our the another ball is hitting, sorry, the ball here, the ball is happening round here, and then it is hitting this one. We don't know about the angle or any other thing. It just because it shows like this image, and we are believing it that it's just because of this angle or everything are in the explainable AI. This explainable AI, because this one is the explainable AI. The angle here shows that this angle will directly hit that stem pulse. Okay, so this is where our explainable AI does, and this is one of the major example in our you can take it as an explainable AI in our computer vision part. Just because if we know the angle only, we can able to predict it, right? That's what happening here too. Okay, so in industries inspection too, we can go with that visualization, like which helps technicians understand the defects and reduces the misclassifications. We can the computer vision is in any area. If he uses images, then the computer vision is there to predict something. So we can incorporate healthcare as well as our industry, manufacturing units. We can go with, and now come to our end, and these are all the references which I have used to take the case studies. At the end of this video, and as well as the end of this module, I will give you the case studies. You have to read those case studies and get more interest from those. As we come to the last part of this video, and I want to summarize what all we have seen so far in this video. Across many domains like healthcare, finance, criminal justice, education, autonomous system, manufacturing industries, energy industries, NLPs, and computer vision, explainable AI transform all the black box model into a system which human can trust, understand, and act upon. Interpretability is not just a technical one, it's an ethical, legal, and practical necessity in real world AI deployments. The case studies we have discussed demonstrated how explainable AI improves trust, accountability, and impact. Am I right? Okay, now I want to move into a conclusion of this introduction section. Like we have seen so many things in the introduction. From the introduction of the machine learning, what is interpretability, what is the trade-off between interpretability and accuracy, what is black box model, what is white box model, everything we have seen. Okay, I want to conclude by saying that explainable AI is to explained to explainable AI is used to explain why I made this justification, why I does this, why I discover these things, why I need to improve these things, or why I made this improvement. Okay, it will explain why I made these kind of decision, these kind of justification, why I discover these kind of things from this data, why I discovered. So if you want to know why your model tests, then that's where explainable AI is there. Okay, so thank you all. You will be seen in the next part of this course. We will explore specific techniques used to achieve interpretability, and you will explore more and more machine learning models as well as the explainable AI models, as well as the ethical consideration in future modules. Thank you all. Thank you once again.